right, I'm going to go over Unit 10 triangles. I'm going to do topics 1 and 2 in one video, and then I'll do 3, 4, and 5 in different videos. So the first topic we want to talk about is simplifying radicals. And this is something that you've already done, so this is really just a little bit of a review. And at this point, we're just going to have you do it in your calculator. So if you take a look at your calculator, if you're not sure how to do this in your calculator, you just Google it, and I'm sure you can figure it out. But for instance, if you want to take the square root of 81, you have to find your square root button on your calculator, and then just type in 81 and hit enter, and it'll tell you it's 9. If you wanted to do something like 4 times the square root of 18, again, you're just going to go into your calculator. You're going to say 4 times. You have to find your square root button, type in 18, and then hit enter, and you'll get 16.9705, blah, 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 blah. So try that out. If you have questions, let me know. And again, if you're not sure how to do it on your calculator, the easiest thing to do is just to Google it. So the next thing I really want to talk about, which is a really big topic in geometry, is the Pythagorean theorem. The Pythagorean theorem can be used for any right triangle. So here you have a right triangle. And as long as you know two sides of the triangle, any two sides, you can always find the third side. So if I have some triangle, I'm going to start with just letters, and then we'll move to numbers, A, B, and C. It's a right triangle. Remember, this symbol tells you it's a right triangle. A and B are called legs. The two sides that are joined by the right angle are called legs. And this is, of course, your hypotenuse. The hypotenuse is always opposite the 90-degree angle. It is also always the longest side of the triangle. And the Pythagorean theorem states that a squared plus b squared always has to equal c squared. So some people call this leg squared plus leg squared equals hypotenuse squared, because it doesn't really matter which side I call A and B. I could just as easily call this side B and this side A, and it's not going to mess up your calculations at all. As long as you don't confuse C, because C is always the one that's at the other side of the equal sign. So let's just take up some example. It doesn't really matter. We can just make up any old example we want. Let's just say, I don't know, this side is 5 and this side is 8, and we want to know what this side is. So because it's a right triangle and I know two sides of the triangle, I can solve for the third side. This is a leg and this is a leg, so I can call this side A, and I can call this side B and this side C. So if I had a squared plus b squared equals c squared, I'm just going to substitute in what I know. This a would be 5 squared, plus this other leg is 8, so 8 squared equals, this is the one I don't know, so I'm going to call that x squared. Just go to my calculator. 5 squared is 25, plus 8 squared is 64, equals x squared. I'm going to add these two numbers together. So I'm going to get 89 equals x squared. In order to solve for this, I have to take the square root of both sides. And when you're taking the square root of both sides, if you remember from Algebra 1, you actually get plus or minus the square root of 89. Anytime you have a square, you have two answers. But since I'm solving for the side length of a triangle, this will never be negative. So I can just really throw away the negative answer and just keep the positive answer. And I'm just going to go to my calculator and type in the square root of 89 and hit equals, and I'm going to round to one decimal place, so 9.4. And it's always a good idea to kind of check it to see if your answer makes sense. If this is 9.4, it's the hypotenuse of the triangle, so it should be the longest side of the triangle, and you can see that it is. Let's try another example when we're not solving for the hypotenuse, however. What about if I have a right triangle? Let's draw the right triangle differently, so that's not always the same. Let's just draw it like this, just so that it's not always the same. There we go. There's my right triangle. And again, This shows you where your legs are. It connects the two legs. So this is a leg and this is a leg. This is your hypotenuse. Let's say I know that this is 6 and this is 10, and I want to know what this leg is. Again, it doesn't matter which leg I call A or B. It doesn't really matter. Let's call this one A, this one B. But this is the hypotenuse because it's opposite the 90 degrees. So I'm going to call that one C. Again, my theorem is A squared plus B squared equals C squared. I'm going to write in what I know. Well, I don't know A, but I called it X. So that'll be X squared. B was 6, so that'll be 6 squared, equals C was 10, so that'll be 10 squared. Simplify my squares, so that'll be X squared plus 36 equals 100. I'm going to subtract 36 from both sides to get X squared alone. This here would be 64. 100 minus 36 is 64. And I'm going to take the square root of that. And again, either you know it or you can go to your calculator and take a look and take the square root of 64. Whoops. And hit enter, and your answer will be 8. Now, once again, your answer is really plus or minus 8. But again, I'm talking about the side of a triangle. So my answer is just simply 8. So that's the Pythagorean theorem. I'm going to do one more where I'm not having whole numbers. Let's have a triangle like this. And let's say this is the square root of 3, and this is 2 times the square root of 8, for instance. Now, that's not simplified, but it doesn't matter. So once again, I'm going to call this A. I'm going to call this B. I know these are my two legs because it's what the right angle is joining, and this here is my C. My Pythagorean theorem says A squared plus B squared equals C squared. I'm going to plug in what I know. Well, I said A was the square root of 3, and I'm going to have to square that, plus B squared, which I don't know. B is up here. I don't know that. And 2 times the square root of 8, but I'm going to have to square that. So you could put this in your calculator and just go the square root of 3 times the square root of 3, and it'll give you the answer. But anytime you square a square root, what you're really doing is just saying this is the same thing as the square root of 3 squared, but you know the square root of 9 is just 3. So anytime you square a square root, you're going to get the number back again. For instance, if I had the square root of 5 and I squared it, I would just get 5. If I had the square root of 8 and squared it, I would get 8. If I had the square root of 241 and I squared it, I would get 241. Okay, so that's how that would work. So this would be 3 plus B squared equals, well, let's take a look at this one's a little different than this one because I have a number in front. So this is like saying 2 times the square root of 8 times 2 times the square root of 8. Well, if I multiply these two numbers together, I'm going to get 4. And if I multiply the square root of 8 times the square root of 8, I'm just going to simply get 8. So this would actually be 32. But again, you could also just go to your calculator and put it in parentheses, 2 times the square root of 8, and then square it, and you'll still get 32. All right, so now I know that I have this. I'm going to subtract 3 from both sides. I'm going to get B squared equals 29. B is going to be plus or minus the square root of 29. But again, I don't care about the negative answer because the length of a triangle can't be negative. So I'm just going to take the positive answer. And I will go to my calculator and I'll go the square root of 29 and it equals, and I'll get B is 5.4 if I round it to one decimal place. So if you have any questions on the Pythagorean theorem, let me know.